And Tom, that is a good understanding. That's affirmative. Station, this is Houston. Are you ready for the event?
And station is ready.
Houston, ACR, this is Mission Control. Please call station for a voice check.
Station, this is Houston ACR. How do you hear me?
ACR, how do you hear me?
And station has you loud and clear.
Please stand by for opening remarks.
Hello and good day. I'm Cadet Captain Lou Sandoval, the Nevada Wing Cadet Advisory Council Chair, and I welcome you all to the virtual downlink with the astronauts in the International Space Station. I would like to take a second to thank our guests for their time and participation, as well as to those who helped make this rare and extraordinary opportunity happen. I hope you all enjoy yourselves and you guys have fun. Now, let's hear our first question.
Hi, my name is Dwayne Grasmick, and my question to you is how often do you see irregular surface activity from the station?
Well, we see irregular and regular activity on a daily basis. I'd say we see irregular activity as often as it happens. So if there's major weather events on the Earth, they can ask us to take a look at those. We also see what I would call irregular activity that unfortunately happens all the time. So large forests that are being burned to clear, we can see that from space. You can see large rings of the orange from the fire. Smoke you can see really easily. If there's volcanic events, we can see that really easily. So yeah, pretty much anything there's a global scale event, we can see it from here.
Hi, my name is Dana, and my question is, if there's zero gravity in space, how do you drink water while at the International Space Station?
Well, Dana, as your question implies, it's a little different up here drinking water. It's actually not a zero gravity environment. That's a bit of a misnomer. We're actually just in free fall around the Earth at the same rate as everything around us. So from our perspective, it feels like we're nearly weightless. But in reality, gravity is acting on us, or else we wouldn't be in orbit around the Earth. We actually drink water from bags with straws, and water behaves a bit differently up here because it naturally wants to form a sphere and float. So I'm going to float up to the camera and do a little demo, and Raj will tell you what I'm doing.
So like Kayla said, normally when we drink water, it's contained in bags, but otherwise it would get all over the place and attach to different things. But as you'll see, she's going to let a little bit out there, and you can see it turns into spheres. And then, like she mentioned, it's just free-floating with us. You can see the surface tension kind of holds it in the shape of the sphere, and you can try to guide it around as she's doing with the straw. And every once in a while, little pieces break free if the force of that straw exceeds the surface tension force of the water.
Hi, my name is David Crowder, and my question is, how does microgravity affect 3D printing?
I'm glad you asked, David. So actually, we have some 3D printing going on in the module that's behind the camera. It's in the Columbus module. And so far, what we found and what the researchers have found is it actually behaves pretty similarly to what it does on Earth. What we're continuing to gain experience up here, but some of the early questions were just whether it was possible. And so we've answered that it is possible to do 3D printing in space. And now they're starting to explore other materials, different types of whether we can eventually move on to alloys and different shapes to see how the process may differ or can be improved from what we do on Earth. But it is working and still in the exploratory stages.
Hi, my name is Gavin Ashby. I was just wondering, what advice would you give a young person that wants to become an astronaut? What are some things they can do in being 14 years old that would really help them advance their education skills and hopefully one day become an astronaut as well?
First and foremost, I would say there is no one path to becoming an astronaut. It's easy to look at astronauts like Raj and I and think you have to follow similar paths. You know, both of us are in the military, but actually you can come from any background. Half of our office comes from a civilian background as well, so scientists, engineers, medical doctors, people who work in industry or in academia. So I think the most important thing you'll see across our office and our colleagues is that everybody really did something they were passionate about. They challenged themselves, but they were doing something that they really thought was fun, that they were interested in, that they cared about deeply, and that made those challenges awesome along the way, even though they were hard. And then the other common trait, I think, is all of us have learned how to work really well on teams. Human spaceflight is not something you can do by yourself. And so developing the skills to work well with others, people from different perspectives with different areas of expertise, is probably the most important skill that you can develop at a young age through things like you're doing in the Civil Air Patrol or athletics or projects at school, projects in your community. I think developing those skills early can go a long way.
Hello, my name is Luz Sandoval, and my question is, what kind of emergency procedures do you guys have on the International Space Station in order to keep oxygen flowing in case electrolysis is unable to be completed?
So that's a really good and informed question, Luz. So the oxygen generation system is actually a few different systems on the space station. So there's some redundancy built in, but essentially what it does is takes a combination of water, carbon dioxide, oxygen, and remixes those in different ways using electrolysis, as you mentioned. So we break down water, we break down carbon dioxide, and then reform it into oxygen, dump methane overboard, and then continue to process out the carbon dioxide. But your question is, if that system were to break down, we do have some backups. So specifically, we have high-pressure oxygen tanks that are outside the station that are plumbed into the inside of the station. So if the oxygen generation system broke down, we could then pump that oxygen into the station and sustain ourselves for a pretty long time with that. On the Russian side, they also have another life support system, and then the European module also has a life support system. So there's essentially multiple systems that are all capable of generating oxygen, and we run them all at a pretty, not at their max capacity to preserve some redundancy.
Hello, I'm Cadet Staff Sergeant Anthony Milano, and my question is, for new companies like SpaceX and Blue Origin, where do you see the future astronauts who are currently in high school being placed in space? Will it be a new base on Mars or the Moon, or will it be continuing a new space station or new spaceships like Starship or SpaceX?
Hi, Anthony. It's an amazing time, as you mentioned, to be a part of human spaceflight. We have so many different vehicles that can carry human beings into orbit and to different destinations, and it's really exciting to be a part of it. Raj and I both came up here on a SpaceX Crew Dragon that brought us to the space station for our 6-month mission, and it's amazing what these public-private partnerships can do when we partner with industry and bring their innovation and new ideas into our government spaceflight program. I think for our careers, what we're really looking forward to is the return to the moon as part of the Artemis program. We are aiming to land the first woman and next man on the moon in the next couple of years, and it's going to be so exciting to go back to build a permanent human presence on the moon, habitats, rovers, using resources in situ, doing some amazing science and engineering work there. And that's all to prepare us to go on to Mars, which might be the destination for you guys. Those of you who decide to pursue a career in space exploration, whether that's as an astronaut or as a scientist or engineer on the ground, maybe a flight controller at NASA even, you'll be running missions to Mars, which will be really exciting work.
Hi, my name is Ian McDonald. My question for you is, what's it like to take off from Earth in a rocket?
It's like a great amusement ride. It's the short answer. So Kayla and I got to come up on the Crew Dragon, and honestly, it felt a lot like the simulators. We've been training for so long that the sounds, the sensations, the displays we were seeing all seemed very much like what we had trained. The only difference is you were moving. And I think initially, to me, it felt like I was in an elevator going up really fast. It was amazingly smooth. I was expecting a lot more vibrations and rumbling, but between the the sound insulation and then the helmet, you could definitely hear it, but it was not as loud as I expected, and it felt, like I said, like an elevator going up really fast. And then I think for me, the first time I thought that I was really realized I was on a rocket was when the first stage stopped and the second stage lit. And so we basically got thrown forward in our seats as the first stage cuts off and separates, and you're essentially in some weightlessness for a while, and then the second stage ignites and you get thrown back the other way in your seat. And so that was a pretty cool ride. And then once the second stage cuts off and you start to feel yourself lighten the straps and you loosen the straps a little bit, that's your first real experience of the weightlessness sensation. It was a great day, and we were all high-fiving and quite excited for the ride.
Hi, my name is Yvonne Altunen, and my question is if your perspective of humanity changed at all once you saw Earth from space.
I think the view of Earth from space really changes all of our perspectives. I think a few things that stand out is just realizing how interconnected our planet is. It's easy to look at the maps you often see in school with these artificial borders drawn on that don't exist in real life, but seeing it from space as the Earth as this single living, connected organism is really spectacular and kind of just drives home how much we all need to work together to protect our planet. You see the atmosphere and how thin and fragile it is, and how important it is for us to do everything we can to preserve this gorgeous, wonderful planet for future generations.
Hi, my name is Michael Ramirez, and my question is, what is your favorite part of astronaut training?
For me, Michael, I think it's the people. And so I was in the class of 2017 along with Kayla and the rest of my Turtle classmates. And I think, one of the reasons I applied again, so I applied multiple times to become an astronaut, and one of the big reasons I applied the second time was because I had so much fun meeting the people who had applied the first time. And I think as I've gotten older, I've realized it's not so much what you're doing at work, it's who you're doing it with. And so for me, that was the best part about training. And then specifically within that, we took trips to different NASA centers, and it was amazing to me. I had no idea how much NASA does around the country. You would think I would know that, having applied to be an astronaut, but it was very eye-opening to see, whether it's aerospace, space, human space flight, planetary science, geology. There's so many ologies and sciences that NASA's a part of and making cutting-edge contributions to. And so going to all the centers and seeing all those specialties was for me the most exciting part. And in doing it with my best friends just made it even better.
Hi, my name is Coy Shelton, and my question for you is what motivated you to become an astronaut?
My answer to that question is really similar to Raja's answer, the people. For me, I was always interested in challenging myself so that I could develop the skills to give back to my country, to my community, and to the world. I wanted to challenge myself and serve, and that's how I found myself in the Navy and serving in the submarine force. And it wasn't until after I had that experience of serving aboard a submarine and really understanding what it took to work on a team in a really complex technical, engineering, operational, mission-oriented environment that I realized all the connections between that and flying in space, and realized how awesome it would be to work with the incredible human beings that work at NASA and dedicate their lives to the mission of exploring space and furthering our understanding of our planet. And so that was really the dream, to join this incredible team, and it's a huge privilege to get to do it as an astronaut aboard the space station.
Hi, my name is Rachel Crowder, and my question is, do constellations look different from the space station?
So stars in general look a little different. I'd say it's one of the things, and most of our windows look down. And so although we have great views of the Earth, we don't usually get to see the stars since that's above the space station. Kayla did a spacewalk earlier in our mission up here, and so I think one of the highlights for her, she'd probably tell you more if we had more time, was getting to see those with a full view. So what we can though see is the horizon above the Earth, and I will say the stars are definitely, they look like you could just reach out and touch them. They're still points of light, but they look much more clear and they're not twinkling. And then the sun actually looks like a giant star. So unlike the orange ball you're used to seeing on the Earth, the sun just looks like a super bright point source of light that you can't really, it's really painful actually to look anywhere near it. You have to close your eyes and try to put something between it. But it's pretty fantastic to be able to see some days, you know, the sun coming up, the aurora on one part of the horizon, a crescent moon. It's just a really beautiful combination of celestial objects on a daily basis that we're lucky enough to get to see, thanks to the folks supporting us to keep the station up here 365 days a year.
Hi, my name is Maximus Flar, and my question is, what type of experiments are you currently doing on the International Space Station?
It's an awesome time to be asking that question because right now we actually have a Cargo Dragon vehicle here that brought us some amazing science experiments. We're actually executing over 350 experiments during our 6 months up here on the space station, and right now it's science season. We have so much going on. We're always doing experiments on our own bodies. We're trying to understand how the human body responds to the spaceflight environment, from radiation, being in a apparent microgravity environment, all of those things. But we're also doing a lot of cool technology demonstrations to try to understand how to make our time up here and on future missions more efficient. We actually have one right next to us right here that was working on yesterday. We have these robots called Astrobees. They're actually free-flying robots that can take different sensor payloads and fly around the space station and do things like cargo operations, looking for lost items, or doing acoustic surveys. That's what I was working on yesterday. So there's always something new and different going on up here.
Jax Bedrini, I was wondering what the physical standards are for astronauts.
So there's basically you have to be able to, you know, survive here in space and be able to survive on a launch vehicle. You know, it varies. Like Kayla mentioned, we all have really different backgrounds in the office. Some of us came from the military, some of us came from civilian backgrounds, but I think all of us did something where there was some kind of outdoor component or some kind of active component as part of that. You know, there are some height restrictions based on the launch vehicles, so physically being able to fit in the seat. But I would say generally, if you're able to lead an active lifestyle, that's essentially the minimum requirement. We do get tested on an annual basis, and more to make sure that we are sustaining our physical ability, especially when we come back from space, to make sure that our bone density hasn't changed, our muscle density hasn't changed. So there's a lot of annual testing, but there's not really hard requirements. It's more to make sure that you're still capable of executing the mission.
My name is Caitlin Cottrell, and I was wondering, how long does it take to grow a garden in space?
You'd be surprised to learn maybe that growing a garden in space is actually a lot like growing a garden on Earth. The plants need all the same things. They need the right temperature, the right humidity levels, they need to be watered, they need light. So we need to supply all of those same things, the nutrients to the plants. But some of those things are a little bit harder to do up here, like how to tell if you've watered a plant correctly, because it's hard to see, you know, if it's wilting, if it's not getting enough water, getting enough nutrients and water to their root systems. But we're able to grow gardens up here. In fact, when we arrived, there was a pretty good garden growing of chilies. We grew some hatched chilies up here and got to participate in the final harvest of that experiment, which included a taco night with fresh chilies. So it's pretty cool to see how we might be able to grow our own fresh food in space. We have a couple experiments going on right now helping us understand how plants adapt to microgravity, and that will inform future plant studies.
Hi, my name is Hannah Cottrell, and I was wondering, how do you guys keep up with your water supply?
Hi, Shauna. So it kind of relates to the question earlier about oxygen. So it's all tied together in the same, what we call environmental control system. So not only our oxygen, but our CO2 removal and then water generation. And the short answer is we recycle our water. That's how we keep up with most of our water supply. And that's one of the, to me, one of the most exciting parts of the technology that we explore and are demonstrating up here and trying to improve on. is, not only is there applications to be able to recycle water on the moon for sustained presence or on a Mars mission, but more importantly, for the people of Earth, if we could come up with a closed-loop system of recycling all our wastewater, that would revolutionize the world. And so up here, we actually drink our own pee after it's been processed, of course. And so we run about 80 to 90% efficiency in reclaiming water, whether it's our pee, whether it's our sweat, whether it's the moisture and the breath we exhale. All that is reclaimed by filters and then reprocessed and then regenerated. Now, we do have the ability to also pump in fresh water when cargo vehicles come up. Sometimes we'll augment the reclaimed water. Like I said, we're about 80 to 90% efficient. So we do have to augment with fresh water, but by and large, we're able to recycle and reclaim all the water that we use up here and use it again.
Hello, my name is Oscar Colbert, and my question is, what do you guys do in your free time?
All sorts of things. One favorite is looking out the window by ourselves or together if we can get a crowd together to see an awesome sight. We take a lot of pictures, both of outside and of what's going on inside, read books. On New Year's Eve, we had a dance party, so just about anything you do on the ground in your free time, you can do up here. We like to have a good time, spend time together, and get together as a crew whenever we can to share, normal human moments.
Hi, I'm Timothy Gelfer, a cadet from the Nevada Wing. On behalf of everyone at Nevada Wing Civil Air Patrol, we would like to thank NASA and the astronauts for answering our questions today. Thank you for helping inspire our cadets to learn more about space, as well as hopefully inspiring them to be future aerospace leaders in the U.S. and around the world.
Thanks very much to the Civil Air Patrol and from Expedition 66 to you guys. Hope you have a great 2022, and see ya.
Station, this is Houston ACR. That concludes the event.
Thank you to all participants. Station, we are now resuming operational audio communications.